one thing that I know is that whatever format I choose, it's going to change. So one of the first things that you design is a model where change is possible. Another thing that I could also build a system that is very rigid, and I could be, maybe I'm a day faster with delivering it, but it can never change. So if you want to rebuild that into something you can change, you're going to run into trouble because the old data, what are you going to do with that? You can migrate it, but this is all extra work. One of the things that I always do is I'm always backwards compatible in anything I make. And that is a key to be able to work iteratively.
Hello and welcome to the Pybites podcast, where we talk about Python, career, and mindset. We're your hosts. I'm Julian Sapera.
And I am Bob Bulthuis. If you're looking to improve your Python, your career, and learn the mindset for success, this is the podcast for you. Let's get started. Hello and welcome everybody to the Pybites podcast. This is Bob Bulthuis and I'm here with Elmer Bulthuis. Elmer, welcome to the show.
Hi, thank you very much.
All right, let's check in. We are recording. I think we have done both our workout today, so we're off to a good start today, right?
Yes, in the morning. Every morning, almost every morning I like to work out. It keeps me sane, basically,
Yeah, it's probably the best hour you can spend every day.
Yeah, definitely, yeah. If you do like a nice workout in the morning, then it's already a successful day. No matter what happens in this positive vibes, you can carry that all through the day.
Everything
and it's a physical exercise. My work is, of course, mainly in my mind.
Yeah.
And to keep the balance, I like to work out.
Yeah.
But also,
so tell us a bit about your work and your background. Who is Elmer?
Yeah. I started with computers a very long time ago. I think I was 8 when I did my first thing. It was a batch file in MS-DOS. My father, he got a computer for work, and this was a 12 megahertz machine, which was incredibly fast for that era. It had a 20 megabyte hard disk, which was insane because nobody had a hard disk. So this was like top of the line. This was like the best computer. Also, we had a printer, which was very interesting because people in school, they made fun of me because I had a printer. Nobody had a printer. And so that's where it all started. And later, I worked with the Commodore 64. Much later, I got a job at Commodore, actually. And that was my last real job, or my last job that I worked for somebody else. Because after that, I started a couple of companies. And also, I did a lot of freelance work. Nowadays, I call myself an interim software and infrastructure engineer. So basically, I help companies with their software and infrastructure problems. And I work with a lot of startups, but also corporates, and both of them are very interesting. So I worked with quite a few languages in my life, programming languages. I did a lot of C#. I'm doing a lot of C# lately, but it's not my favorite language. I like JavaScript, TypeScript, and Rust. Mm-hmm. Those are my favorites. For the rest, I do some Python. I do some Java from time to time. A lot of Bash, which is actually, it is kind of like a language. And then back in the day, I did PHP. Of course, I do also HTML. I do React, but not because I like it. I'm more a fan of web components because it's just a better solution, I think. But, the world wants React and everything. So, I do front end as well. Infrastructure, also databases and architecture and whatever. The only thing I don't do is everything I make is ugly. It looks like shit. But I'm absolutely not a graphical designer. Everything I have 2 beautiful children. That's the most beautiful thing I created ever. Well, it always is, of course. But if I design a website, it looks terrible. So other people are much better at that kind of stuff. Yeah. I have a degree in interaction
clean code,
right?
Sorry? You do like the beauty in code.
Yeah, I think my code is nice. It looks beautiful. I think it's important that code looks beautiful. You have to look at it, right? So. Yeah, and so I got a degree in interaction design. I'm not a good interaction designer. I only did that because everybody was expecting me to do computer science. So I didn't do that. So I did something else, interaction design, which is actually also a lot of programming. And I'm a really bad interaction designer. So but I just stick to the code. Yeah, and everything that comes with it.
Yeah, and we're definitely going to dive into it because with all that experience, I want to distill the lessons. We're going to talk about Rust, WASM, abstractions, testing, design.
Cool.
But before we dive into it, do you have a win of the week?
A win of the week?
Yes.
Well, I have a win of the past weeks, months. Choose your battles. It's kind of an open door. So, you don't always agree with the rest of the world. Usually you don't, because most people are other people and they have other opinions than you. But that does not have to be a problem. You don't have to change everything, just the things that matter. And all this energy, you're going to lose it if you're fighting for something very small that is simply not worth it. Yeah. That would be
that's a great mindset win. Yeah.
And it makes you a lot happier. Yeah, which is the most important thing.
You cannot and should not fight all the battles. Will makes you unhappy. Also, become selective. Yeah,
exactly. Like, for instance, code formatting. Do we really care if it's an uppercase or a lowercase? Do you really care? Then
what's the saying? You can be right, or you can be liked or something.
Is that it? I don't know that one.
Yeah.
But I think you're always right, because I'm always right, because if I would think something else, I would say that was the truth. So you're always right.
In
my opinion, I'm right, because I would believe something else if I wasn't. But being right is not the point.
Yeah.
The point is, well, I don't know what the point is. The point is having fun, actually.
Yeah. What about Rust and WASM? You are
I'm very excited about that.
Yeah. So what do you like about them, and how they're
of course
let's start with Rust. Why
Well, of course, what I like about Rust is that that it introduces a whole new paradigm into programming. See, I never saw anything like that, and I'm talking about the borrow checker and the whole concept of ownership. This concept is already there, but it's in your mind. But now it's actually enforced by the compiler, and I like that. It hurts in the beginning, because there's quite a steep learning curve, but it makes you better programming, also in other languages, because you are very aware of what you're actually doing, and this is partially because you have to always think about who owns the thing, the variable in our case, but it's also the other thing I like about it is that everything is very explicit. If you want to make like something that sounds simple, like a note with a parent and a child, so you do this often, probably you see it everywhere. If you want to do that in Rust, it's not so easy, and this is good because it's not easy for your compiler as well, because you have circular reference, and one of them needs to be weak in order for it to be able to collect it properly. So that's one of the things I like, that everything is explicit, and everything that is heavy or at least more heavy things are more code. So this goes perfectly in line with if you have less code, it's probably faster, and that's like a rule of thumb that you can just apply with Rust. It's also why making things that are really fast and really optimal is simpler than making something that is not so fast. It's assuming that you don't clone everything, which is, of course, not how you should do with Rust. But
Well, that's, of course, in the compiled language level, right? So, for example, in Python, it's just abstracted away, and you don't have to care about the memory, right?
Exactly. And it has a whole different use case.
Yeah.
And that's only, I think the use case for Rust can be very broad. It's very expressive. People use it a lot for system level software. I think that actually Microsoft was planning on rebuilding their entire kernel in Rust, and they want to have it done by AI or something like that. That was like a rumor, which is, I don't know if that's actually going to happen, but it says something. It's very suitable for those kinds of things. But I think also that Rust is very suitable for back-end programming, and one day maybe even front-end. And that would be then via WASM, which is it's a great technology that actually goes hand in hand with Rust. And I think that is, Rust was really early with being able to compile to WASM. And they can be really early because they have no garbage collector. They don't need a garbage collector. That's all handled by basically by the compiler at the compile time. But WASM is, it started out as, what's it called? It started out as a JavaScript library. And it was called mscriptendem, I think. And it was actually, there's actually a site that you can play Doom in your browser. And that was like years ago. That was, actually it was impossible, but you see it and you wouldn't even believe it. It was Doom compiled to JavaScript. What it did is they made a bytecode, which is now the WASM code. And they had like a runtime built in JavaScript. So you could compile your Doom in this case to something that runs in your browser in JavaScript. And that's completely amazing. And I think this is this already happened. We're already past that because now you can run native WASM in your browser. But if you think about it, JavaScript is actually the biggest language. It runs literally everywhere. It runs on your phone.
Right.
You know how many phones there are. It's insane. And now with Node, you have it on, server as well. So it's literally everywhere. Now you have this bytecode that actually runs on JavaScript. So it will also runs everywhere. And I think that was the beginning of the success of something like WASM, because you have absolutely no friction in using it. You can use it everywhere. Nowadays, you can run WASM in your browser, which is great. But I think we're still not where we want to be. If you wanna manipulate the DOM with WebAssembly, that will be great. And now you do it via interrupts still, I believe. But there are things happening that you can directly manipulate your DOM from your WASM code, and then you can literally use any language in your browser. And this is only one use case, of course.
Yeah. So I'm new to WASM. So it's sort of a translation tool from one language to the other. In this case, you can write Rust and then run it in the browser. It stands for web.
It stands for WebAssembly, and web, of course, comes from because it started out in the browser. Assembly is like it's where all languages compile to, and it's similar to Java bytecode or maybe the .NET CLR. So it's a universe. It's compiled to a format that you can use anywhere. And anywhere in this case means your browser, because then you can have it run by JavaScript or natively in your browser. But also, there are plenty of runners that run on your own machine or in the cloud. And so it's comparable to assembly, but it runs everywhere. So this assembly is normally compiled with a target that is your CPU. So if you run it on an AMD, you have a different code than it runs on Intel. So that's and it's any language. I mean, I know that Go and Rust at least, and I think also Java can be compiled to WebAssembly, and they're coming more and more. A lot of languages compiled to WebAssembly. So this is kind of what Java tried with the Java bytecode, to have one format that runs everywhere, and Microsoft tried it with CLR, which is one format that runs everywhere. But the whole CLR is tied to .NET. Java bytecode is tied to Java. WASM isn't tied to anything. So you could literally run everything with WebAssembly. And this is happening already.
Yeah.
But you don't really see it.
Do you have any cool projects where you use WASM? And
I have I'm working on a JSON schema compiler, which compiles JSON schema into it's currently TypeScript and Rust, and there is some interesting logic there that's quite complex. So I build it in WebAssembly, or I build it in Rust, compile it to WebAssembly. I can use it in different languages.
Okay.
So I use it in, I built the TypeScript compiler in TypeScript. I built the Rust compiler in Rust. And there will be a .NET compiler that I build in .NET. But the core logic, it's quite complex and hard to test and everything. So it's nice if you can reuse that.
Yeah.
That's what I use it for nowadays.
Yeah.
But I can't wait for this to be big. It's also much faster than most languages.
And people can check that out on your GitHub, right? We can link that.
It's so github.com/loftussen. Yeah.
I'll link that. Cool. Let's talk about building things actually and the making process. Where shall we start?
Maker mindset. Well, it
Maker to
reminds me.
MVP.
I know somebody who is she makes furniture.
Yeah.
And she showed me you had like two pieces of wood, and there was some kind of connection, and they were put together.
Uh-huh.
They would fit perfectly, and and I thought it was really sexy. And that is the same feeling that you get when you make something that is actually absolutely beautiful. So I think this maker's mindset, if you make something in software, it's the same thing as making something in a furniture. I think there are similarities, but it's the joy of making something that is that is just perfect or sexy, or how you would call it. I don't know.
Yeah. And it's kind of related to the next question I have.
Yeah.
The designing things in your head first. Can you tell me a bit about your progress? Your process of going from idea to MVP, right? Because you definitely don't code it straight away at the terminal. You do a lot of design up front, right? And mostly in your head or with pen and paper. Is that correct?
It all happens. There are two things that I think are really important. I think a lot about it before I put it down. Actually, I use my computer to dump my thoughts in. That's kind of it. And of course, there may be some tweaking, but most of the work is done before I even touch my computer. And it happens, I think also in a way, programming behind your computer can be distracting. Especially if you're designing something that is complex, you need to take away all those hurdles. You need no distraction. You just need to be. So this works for me. This works best on a piece of paper, and maybe I draw a line or something. It doesn't really it doesn't really look like anything, but it helps me think. So I use a piece of paper very often as a way to organize my thoughts. It's not like I'm making a list or anything. That is, but I think that is a very, programming has many aspects. And I think one very important aspect of programming is planning, actually. And this planning is something that you should do not while you're coding, because then you're actually doing it and not planning it. Yeah. And I think with the planning also comes a very important aspect. And that is, I really like to work iteratively. I only work iteratively. That's way faster than anything that else, actually. Well, in a way, working iteratively is working in very small waterfalls. But I take small steps, and I just do the things that I'm sure, because especially when you have a client, they don't know what they want until they see it. Yeah. So I think it is very important to start with something. And usually I start out with something that I know that they are going to need. That's the one thing. And the second thing is that I start out with something that I know that's going to be a risk. If you do something for the very first time, that's a risk, If you're not sure if something works the way that you think it works, that's a risk. And that's a really... it's a really simple, actually. It's, to put it in practice might be a little bit harder, but it's a way to go way faster. Yeah. The first thing you deliver does nothing interesting. You can only log in, maybe. And the second thing does nothing interesting, and the third thing does something interesting already. You can get to that third version really quickly if you get if you practice this. Yeah. So those
my
are
experience as well, right?
Sorry?
It's my experience as well. You make a mind map. At least you have an overview of the components. Yeah. But then focus on that core feature and get it out to people as soon as possible for feedback, because everything is going to change.
That's the only thing that's not going to change. But that's the only thing. But it goes also with, like, I'm currently designing a system, and what we're doing is we are storing data that cannot be, it's like a system where you store logs, but these logs, they need to be in a format that they cannot be changed. And if they are changed, it needs to stand out. So they can be used for forensic analysis and whatever. So one thing that I know is that whatever format I choose, it's going to change. So one of the first things that you design is a model where change is possible. And these are the things that are necessary to get to work iteratively. Another thing that I could do, I could also build a system that is very rigid, and I could be, maybe I'm a day faster with delivering it, but it can never change. So if you want to rebuild that into something you can change, you're going to run into trouble, because the old data, what are you going to do with that? You can migrate it, but this is all extra work.
Right.
So, but this is all part of the whole planning thing, right? So, if you know, and I think one of the things that I always do is I'm always backwards compatible in anything I make, and that is a key to be able to work iteratively. Like, for instance, also, even if you have an API, imagine that your API is only consumed by yourself. Even then, you want to be backwards compatible, because you can just, they're not dependent on each other. They can move in their own fashion, and there's always something. If you build an API and it's completely backwards compatible, which is pretty well, it's easy to do if you know how. Then you can just release it and everything works as it did. And then you can have a next version that uses this API. In reality, what happens is you're gonna release that API, and then something happens, and you cannot release the other thing. But it's not a problem now. And so these kinds of delays, in if you're building something, anything can happen. So that's one of the things that I always do. Stay backwards compatible in iterations, and always look for things that can. I think they call it a critical path. Yeah. So if there's a thing and it's critical that it happens. So I don't know if you have like database is also a very good example. Always keep your database schema backwards compatible. It's possible. Just don't change the whole thing and expect it to just take baby steps. Because if you change the entire database schema in a non-compatible way, then this is on the critical path. And that means that if it goes wrong, the whole project is stopped.
Yeah.
The whole project needs to wait for it.
For the data corruption, right? Good example with database migrations, right? You go step by, it's like the version control of databases.
Yeah, exactly.
Very granular, and you can roll back, you can, basically
rolling back is also incredibly rolling back is that's absolutely right. If you are always backwards compatible, you can roll back, and being able to roll back is a way to sleep at night. Yeah.
Well, imagine, for example, a project like Pydantic, right? That they go to version 2 and they have the whole core rewritten in Rust, right? But then for some reason, a lot of projects can only use the 1.something version, right? So they need to respect it, right? So especially as a library creator, you just have the fact that a lot of your code will be pinned to a version, right?
Yeah, definitely.
You cannot break it. Shouldn't break it. I should never break it, but it's more like a common concern for library.
It's possible, but you need some kind of discipline. One of the best and most interesting examples, I think, and I really love that. In the HTTP specification, they misspelled refer because it's with one R, but in the specification, it's with one R, but in reality, it's with two R's. So they tried to fix that. It's still supported with one R. I think and I think that's a beautiful thing. You should just keep writing it with one R, because this is a specification. It doesn't matter if it's a typo. It's kind of cute in a way, But this is how you should be dealing with your code as well. If you gave a shitty name to a thing, keep the name. It's people will, and maybe if you have a next version or something, maybe you can improve the name. But it doesn't matter, maybe you think it's not a great name, but most of the people that work with your API, they don't really care. Maybe they think, oh, that's a weird name. That's it.
So concretely, instead of renaming the name causing breaking changes, which I've seen in quite some plugins, and has been annoying, make a wrapper function that just calls the old function, for example, right? So now you can still use the old function, but you have a new name that wraps around it, for example, right?
No, but I would just, if you have an API, I would just keep to the name that is not so nice. Right. I think names should be you should really think about how you call your things.
Naming things is hard, but do it right. And
I think it's not. I think it's not that hard. You just have to accept that there's no perfect name.
Yeah,
because
also with understanding the problem, right?
But I think as a rule of thumb, I always use two parts. If it's, mostly I use 2 parts. So it is not it's not a crawler. It's a container crawler. I just named something container crawler. So this is a system that crawls over a container. And if you know the context, and this context is it's the system for Azure, so it's a blob container. And that's the second thing with naming. I think context is really important. If you are in a system and you do something with accounting, then an account is something else than if you're in a system that has sales. And it makes no sense to maybe in one case maybe you call it sales account. Maybe that's even better because it's 2 parts as well. But if you say account, and it's it should be clear because you need to be aware of the context if you work on that system, of course. Yeah. But even if you would make a system for a accounting firm and you call something an account, and then you are working with accountants or something, so then I should not rename that account word to sales account. I would just keep it account. Yeah.
Which I think is a nice segue into the next topic we have, abstractions, right?
Yeah.
But why do you think abstractions are so important, and what makes good abstractions? Maybe examples.
Yeah, abstractions are the whole concept is abstract. So I think abstractions are incredibly important in programming. I think also that that's hard to get right if you just start out. It's something that you get with experience, I think. But it's also it's a way in the end it's a way of thinking. So this is very much, it actually has nothing to do with programming. I think it's more a way of thinking about the world, and also being very rigid about that. If you are not rigid about your abstractions, you get leaky abstractions, and it basically means that one level of abstraction leaks into the other, and that's the beginning of a lot of pain. So abstractions are very important, and also it's a way to improve maintainability, which is incredibly important, I think. If you have a right abstraction, you could make like a base class or something like that, and with the right kind of abstraction, you can use that for years and never change it. So maybe a bit optimistic, but if you don't change it, it's very rare that there are bugs in there. So it's also a good way to achieve quality. There's many upsides to abstractions. But difficult to get right, I guess. And why that is, I know that, because that's really, I think that is really, if you are a developer, that's how you think about things. It's not a very human way to think about things, maybe. I had so what it actually is that, it's a difference between, for instance, like I said, it's very hard to find an example on this because it's all very abstract.
Run from a code base.
I recently had an experience with somebody who, so we had to compare 2 models to each other, and it was in C#, and in C# there's this equality interface that you implement, and then you can compare 2 things. But we found out that we did not want to compare every field in that model. Like for instance, the identified ID should not be compared. In this case, we were verifying if a change came through, and we were not verifying the ID. But if you have 2 objects that you want to know if they're equal to each other, then you should definitely take in account the ID, because the ID is a very important part of the object. It's actually an identifier, which is what ID stands for. So if you have, so it should really be taken into account. And that is an abstract way of thinking. So we have but we wanted to use it for something else. So we introduced the object, what's it called, the equality comparer or something like that. I forgot the name. And this is especially designed to compare 2 different objects to the same objects in a different context. So in the context of verification, if the change went through, we do not take into account the ID. But if you want to know if the objects are the same, then you take into account the ID. Now, these are 2 different things, and that is where abstraction comes to life. So. And so in the end, we wanted to compare the objects, but we found out that strings should be the same as nulls. And at the first moment, we implemented it in the base class for the comparator. This would mean that every time a string is compared, we would say that null is the same as an empty string. But there are cases where this is not the case. Some concrete cases. So
Right.
This was a form of leaky abstraction. We had a bunch of models, and as a coincidence, I think, or maybe as a shortcut, we figured that they were all empty strings were nulls. Implemented it there, but that would get us into trouble later because you do not expect that, not necessarily.
Yeah,
it's a very subtle thing. But it's hard to recognize, I guess. And but it is a very
the
important.
base class and 30 child classes now implicitly get that new behavior, and
Yeah.
I might not have expected that, right?
And you would not expect that exactly, because
Did you introduce another object or another?
Sorry.
Because if you do like another base class, sister base class, and then you have multiple inheritance, that's
You could
inherently complex, right?
Yeah, but you could introduce another level,
Yeah.
another base class, and maybe you should call it. Maybe you could call it like normalized comparer or whatever.
Yeah.
That's one way to solve it. But then another thing is that if you introduce another level of abstraction, you introduce quite a lot of complexity.
Exactly.
If you just coalesce every null with an empty string, then you're done. Only this in a way, this feels bad. I don't think it's bad, but I can imagine that you think that because you're typing these coalesce functions all the time, or coalesce operator is this and .NET, you do it everywhere. It feels like it could feel like a repetition or something like that.
Yeah.
But I think repetition is not necessarily a bad thing if it adds to clarity.
Yeah.
It is unmistakable to see what happens there, and that is a very important thing. I think that is even more important than that is more. It is more important than repeating yourself. If you can make something extra clear that it cannot be misunderstood, then it won't be misunderstood.
No.
If there's an option that it will be misunderstood, it will be misunderstood, and that's also weird. In a code base that is difficult to understand, your development is going to be slower. Going to make more mistakes. It's more difficult to reason about.
Yeah.
I think the most important thing that you can do as a developer is making things simple, and maybe that's also the hardest things you can do. Hardest thing you can do. But if you're able to do that, then you're. That should be your main priority, I think, as a developer. Making simple,
right? Simple is better than complex.
Yeah.
And
Well, complexity is complexity is easy to make. I think very easy.
It comes with a price or a risk.
And sometimes you need complexity, which is terrible. But even if you have complexity, isolate it somewhere. So you do not have to and document it very well and test it very well as well. That's even more important, I think.
Yeah.
And then you can work on levels, so you have like a system that is easy to understand on the surface, but there are parts that are complex. Maybe you don't understand them, but because you made the interface simple, you can work with them. Yeah,
it's all about isolation, right? To have these boundaries, and inevitably there will be complex parts, but can you isolate them and have clear interfaces with them, right?
And if you have
the library is also complex, but it has a nice interface, so you pip install it or include it in your project.
Exactly.
It, but the code might be complex. You might not realize it because the interface is elegant.
Yeah, you don't even have to. I think it's nice to know those kinds of things, how complex, what it actually does. But the complex things, just let them be complex. You don't have to be bothered by that. Yeah.
Just a quick break from the episode. Stuck at the beginner or intermediate level and wondering what it actually takes to become a senior developer? It's not just more years of experience. It's owning projects end to end, making solid design decisions, writing clean, tested code, and communicating like a pro. That's exactly what we help people with inside the Pybites Developer Mindset program. You build real-world apps, get weekly code reviews, and sharpen your developer mindset that will lead to promotions. If If you're serious about stepping up to a senior dev, check out the link in the description and apply right there. Now back to the episode. I want to talk a bit about testing because you have quite a statement there that you think the test code matters more than the production code.
Yeah, I have two very strong statements on testing, and
let's get them out.
You're right. The first one is testing is more important than writing code. It's terrible, but it's true. So beautiful code is worthless without a proper test. It's better to write shitty code which is very well tested instead of beautiful code, bug-free, that is not tested. Because if you don't test it, you don't know if it works, and not knowing if it works means it's broken by definition. Yeah. And even worse, you don't know it's broken. If it is broken, if you have beautiful tests with shitty code, then you know that the code is shit. And you can improve on that. And if you improve, because you have beautiful tests, you know that it is good code. So testing is incredibly important, I think. And the second thing is, I think, also in theory, in practice, it might be a little more friendly, but in theory, humans cannot test. Because we need, in order to have a proper test, you need a stable precondition. Humans are not a stable condition. They are very unstable. And that has its own beautiful traits, but testing is not something that humans can do, should be doing. Also, it's incredibly inefficient. If you have like 100 tests and a human should do all those tests, that's never going to happen. And even if that does happen, then this is a really terrible job, I think. You cannot, if you... like, for instance, also, what happens very often is that you have like a test scenarios. Humans do this. They click through your system and they test all the things. But they always miss the things that are very hard to test. Forgotten password is a very nice example, I think. If you go, how often is the forgot password function tested? I'm pretty sure that is not a well-tested function unless you do it automatically. For instance, I'm working on a system that does payments with a bracelet. There's one scenario that I have that assumes that you have a new bracelet. If I would test that as a human, I would need, for every test, I need a new bracelet.
Yeah,
which
not feasible.
Well, not feasible. I need to have like a very big box of bracelets. And if I test 10 times, which, is an incredible amount of time that takes on a day, then I have my whole house is full with bracelets. So that makes no sense, in my opinion. Of course, you do test sometimes as a human, but I think it's much better to invest in automatic testing for those two reasons. Yeah.
So there are different types of testing: unit, integration, end to end. How do you prioritize? How do you
depends
the order?
I'm very fond of specification by example, which is in a way a test is a specification because the test tells you what to do. Yeah. In specification by example, we kind of assume that people don't understand each other, which is very true. And we can talk about a function forever, and in the end, it's going to be a little bit different in your head than in mine. So we need a better way to communicate those specifications. And specification by example communicates specifications via examples, basically. So imagine you have rock, paper, scissors. I'm doing this example in a workshop in 2 weeks. Only we call it rabbit, carrot, gun. Yeah. Because it's the same thing, but a little more funny. But so if you would explain that to somebody, then you could do that. But I think it's much faster if you give examples. So if you say like, okay, so carrot wins from gun wins from rabbit, rabbit wins from carrot. So now we explain the entire concept.
Yep.
And you need to only if we and now we need to. So this is it cannot be misunderstood. Now all we need is a way to write it down, a proper way to write it down, and then we have a specification. Now the proper way of writing it down is, using the 3 phases of testing, which is arrange, act, assert. In Gherkin, which I like to write things down, it's a given, when, then. So you could say like, given I play a game of rabbit, carrot, gun. And I have a gun, and the other opponent also has a gun, then nobody wins. We have a specification. And
tells a story.
It tells a story. And everybody will understand that. And this is not, maybe you think it's a little bit pedantic or something. I don't know. But it's really clear. And this also works across cultures, which is really important if you work with people from abroad. And if you write it in a structured way, you can also have this automatically tested. But even if you don't do it automatically, this works as a great way of communicating your specifications. So if you test this, then you would go more into end-to-end testing, which I think is also a really interesting way to test. To test for your specifications. I think also to test for bugs. If you encounter a bug in the system, which will happen, then it's great if you can first make an end-to-end test that exposes the bug, and preferably in a way that everybody can read it. So maybe even the one reporting the bug, if it's internal. Then you write a unit test that exposes the bug, and then you fix the bug. The bug is fixed. Unit test passes. This is what you test locally. End-to-end test passes. This you could also test this locally, but usually they take a little bit longer. What happens now is because you have this process of first making a test and then fixing the bug, this bug actually, as a result of the bug, your system is now more stable. The bug happened for some reason, but you can objectively say, I think, that it was a weak spot in the system. Because if it was, bugs happen in weak spots for whatever reason, but it is a weak spot because there was something wrong there. But now you have an extra test in that weak spot, which makes for a more stable system. It will never come back again. Yeah. In order to do so, you really need to follow that process of TDD. So making a test first and then the implementation. Yeah. If you're developing, I'm a little bit more relaxed with TDD, but yeah.
Yeah, it's not always a fit. But I love that flow of, hey, bug, write a test that exposes it, fix it.
Yeah.
And then all the other tests guarantees that you don't mess up anything else, right? So
exactly.
It's really robust. Yeah.
And it's actually a faster way of working, but it seems like a slower way of working. I do some CrossFit as a sport, and one of the things that we say with CrossFit is slow is smooth, smooth is fast, which is very true for CrossFit. But I think also if you talk about software development or maybe especially testing, it kind of fits there as well. If you make a test first, then maybe it feels kind of productive because, you're not fixing the bug, right? You make another unit test, you're not fixing the bug. But then you fix the bug. You never have to test by hand. You can just push a button and see if it works. So that is already a faster way of at least verifying if you're done. And then on top of that, in the future, you change something else and it breaks your code. Now you know. So you only have to fix that bug once.
It's all about the future, right? It takes a bit more time now, but it's going to save you so much debugging and potentially unhappy customers.
And unhappy developers, especially at scale.
A stable system is worth everything, right? So
yeah. And I think also because there's a lot of people talk about quick and dirty, and often a reason to do this is to build something fast, and this then needs to be done because somebody else wants a product or something. I believe in quick.
Now, right?
Sorry,
especially with vibe coding now.
Yeah. Vibe coding is it's a power tool. Yeah. If you use it right, you can really use it to your advantage. Yeah. But if you use it in the wrong way, it's like, if you can destroy a lot of stuff. Yeah.
I mean, experienced developer, of course, use vibe coding in a responsible way, right? But it does create that hype of like quick and dirty, and it can be about some things you cannot shortcut, and testing is one of them, right?
Testing is one of them, but it's also planning that often gets forgotten. The design, and I believe in quick. I don't believe in dirty. You can be quick and clean, and it's not. Just need a little bit of discipline and think about it before you do it. Actually, I think the whole AI hype with coding is it doesn't change a lot. Well, it changes a lot, but it doesn't really change the way you work. Only some things can be done faster. It reminds me of, I remember when internet came up, and back then I was programming, and what I did, I was very young then, I went to the library and they had these books there, and I would take a book and I would copy it in the copy machine. I would take that home and try to understand it at home. So then the internet came, but the work didn't change. Only it's a whole lot faster to just sit behind your computer and look something up than if you need to go to the library and copy stuff and read it back home. It's a lot faster.
Potent tooling, same principle.
Sorry?
Right? And more potent tooling, but same principle. Right?
Yeah, exactly.
Yeah.
Now so this is a revolution that is similar to the internet in that sense. I think we're gonna be able to work a whole lot faster, but we still need to work. Yeah.
The design doesn't change. The fact that you need to write tests doesn't change, but we have better tooling to do it faster.
Maybe we can write tests a little bit faster, write code a little bit faster. And for me, as a person that is only able to make ugly things, I like it that I now can at least put an ugly picture in my ugly code base. It doesn't make it more pretty, but it makes it easier to look at. Yeah.
But are you using AI tooling a lot? Are you in Cloud Code?
I use AI a lot as a for research. I use it as a search engine. I can find things way faster. And sometimes I use it in PRs. So most mistakes I make are stupid mistakes, and AI is very easy to recognize those mistakes.
Yeah,
we're talking about typos, and there's some things that I can never get right. Like if you have two variables and one is earlier than the other, I cannot. That doesn't fit in my head or something, so I always mess that up. And those are little mistakes that you can also get them via testing. But it's good that these are the kinds of things that AI helps me with. And for the rest, I think it's also useful for front end in some scenarios, because in front end you usually have a lot of code that is the same but a little bit different.
Very predictable. Yeah.
Yeah, and I think if there's a pattern to be recognized in what you're making, and you need to repeat that pattern, but not the same, that's really useful with AI, I think.
Yeah. When I was using Tailwind CSS for the platform, just to copy pages, and it was so good at just emulating the CSS classes, or just extrapolating that.
Exactly. But then I start with a good foundation, and I do that by hand and maybe a little bit of AI. But at some point, when you have a foundation that is solid, then it's able to replicate that, and that's very useful, I think.
Yeah, you have to design right, and then you can go very fast. But it still requires you to think through the things well. Yeah.
Well, and also refactoring. So I made a system with Tailwind, and I was not happy with Tailwind. So I said to my what was it? I think it was Copilot. I said, you just make normal classes out of this. And it did that. And they were messy classes. But it gave me a first step into refactoring it into more clean code. So it's also a way to, it's also a way to Kickstarter, basically, to get started something really quick.
I had another question about testing, the design. How do you make your code easier to test? Because, for example, mocking gets complex very quickly, so I prefer dependency injection. Do you have certain go-tos for that? How you make your code?
Well, this is abstraction. Yeah.
Yeah. Right.
So that is the key to having a testable code, I think, and maybe abstraction not though. So one of the things that I like to do with so develop the test and the code at the same time. Mm-hmm. Then you it's testable, and if your code is not testable, spend time on making it testable. And this means restructuring things and stuff like that. Yeah. Like I said, maybe it feels counterproductive because you're not building functionality at that point, but it will speed up your development massively in the end because now your code is testable, so it will be testable. And if you need, it also depends a little bit on what your if you have a function, you want to test a function. All right, that's easy, right? Those are not the most interesting test. But if you have a service that uses other services, then dependency injection could be a very useful design pattern to use. You could mock those services or do whatever. I think mocking could be, in some cases, it's a very good idea. Sometimes it's not. Depends on what your and one thing I always do is I want to be able to, the thing should run locally, really. If it runs locally, it runs in CI, it runs everywhere. I see quite often that, people, they use their AWS or Azure account to test against. Don't do that. I often use Docker Compose, and I run all services that I use in there. And I also run that in CI, which is, I have the same test in CI as I have in a local machine, and it mimics the production environment very, very closely. On top of that, usually I like to build Kubernetes clusters with everything in it. Depends also, of course, also on who I build it for. But I usually have a cluster that I can also run locally. So the thing that I run in production is the same thing that I run locally. And that really helps. It also helps to save costs because, you need the whole function of a staging environment changes. Very often I see people testing in the staging environment, which is actually not the right place to test. But if you run everything locally, and if you have proper testing that uses this local environment, you don't need that. Saves you money, but also, if you work with many people on a team, you need a separate environment for every developer. Who really has that,
Yeah. Which again comes down to how you plan it, break it out, boundaries. Because if your core logic is not dependent on any service and you can just unit test it locally, then you might have 80% reliability in testing already done.
Yeah.
And then leave the services more at the outer onion layer, right?
But I think I would even go that far to select services that are easy to test. But this is where it gets also a little bit more political, I guess. Because if I would be choosing between SQL Server or Postgres, I would choose Postgres for the simple fact alone that I can run it locally. I think even now there's fun fact is that I heard that there's a JavaScript version of Postgres. What they did is they compiled Postgres to WebAssembly and run that from Node. This is perfect for testing, so you don't even need to use Docker Compose for that. I wouldn't do it, but you could do that. And so there has to be a really good reason to use something else, something that is not as testable. Also, for the fact that I mentioned earlier, the testing is more important than the code. So also, I would choose dependencies based on if they are testable. Of course, the dependency needs to meet your requirements. That's the most important thing. But I think being testable is a requirement, an important requirement. Being able to test locally is a very big advantage. Of course, if you want to do all of that, you need a good design to set it up. Like one of the things that I like to do is like to test in a browser. I use Playwright for that nowadays. I used to do it with Selenium, but Playwright is really good. It's really well done. It's Microsoft again, but it's really well done. I really like it also because it works with web components. Love it. But, the principle stays the same. You need if you want to do tests like that, you need a really good design to make it maintainable. And that is one of the key things. If you want to work with tests, you need to also think about, testable code also means that it is maintainable. And having your tests, if your tests are maintainable, it's the only way you can ever, survive this. Because if your tests are not maintainable, what's going to happen if you're going to spend a lot of time in testing at the point where it's really non-productive anymore, and in the end you're not going to run your tests because they're all broken, and in order to fix them, it will take an unreasonable amount of time.
Yeah.
So,
That's such a no-brainer, right? To write a lot of good tests because you have your specification right there, form of documentation, you have your regression suite, so your code is more robust, less risk of future breaking changes.
Yeah.
But then also this whole thing, if you develop them in tandem, that it makes you think so much more about the code. So your design of the code is going to improve a lot because if you're not focused on the test, you might just write code that's not testable, right?
Exactly.
And so that's three major wins.
It kind of enforces the right amount of abstraction a little bit.
Yeah.
It comes, if you have maintainable,
think
testable
differently about the code,
Yeah. And I think this is once again, this is something that you should spend time on, really.
Yeah.
This is if it takes you, I don't know, maybe you make an extra clause and think about that for a day, and then you think like, I should make that clause. Yeah, great, go do it. But don't how do you say that? Don't try to save time on designing your code. This is more important than writing it. This is the only reason why you're a programmer, right? Everybody can write code. Just read the book, use AI, do whatever. But designing it, that's where you can make a difference. That's where the difference is between let's call it a good and a bad programmer. Yeah.
I agree. Cool, man. We went from Rust and WASM to 3 major things, which is design, abstractions, and testing. We're coming to the end. So we always end with a book tip or recommendation. But if you're not currently reading anything cool, maybe a book or resource in the past that has really helped you.
It should be a book about the job, right? About programming.
Well, actually, that's not required. I mean, if you have a cool book in that space, fine. But if you have a work of fiction or art or whatever,
I don't really read a lot of books, to be honest. But
a resource.
Resource. I think. What I okay. Not that. Yeah, it's kind of a resource. So, okay. One resource that will make you better programming is yoga, which is maybe not. Because one of the things that one of the things I learned from yoga is to work with my ego, and I think I'm a better programmer if I am less programming for myself and more programming the right thing. I think all these, I love my job. I like to make something that is completely amazing, but in the end, I'm making it for somebody else. It's not about me; it's about the product. Right. And these kinds of life lessons, there are plenty of more in yoga. They help you become a better person and a better programmer. And I think those two will go hand in hand, by the way. Yeah,
that's awesome. So, that's the first time I hear the yoga programming connection. So how does yoga help with that?
Well, I think in at least 2 ways. One is the physical part of it. Programming is a mental job. It's a intellectual job. But you, as a human, you're not only an intellectual being. You have feelings and a spiritual side and a physical side as well. So these need to be in balance, I think. If they're not in balance, you're going to eventually, you're going to get stressed or whatever. You're going to get all sorts of nasty things. If they are in balance, you can go much faster and much harder on every of them. This is one of the things that yoga does. And like I said, the whole ego thing, I think often in a lot of programming cultures, like companies and everything, sometimes or way too often, I think there's like a competitive culture, but not in a good way, Sometimes I feel like if somebody thinks they're a better programmer and that they're a better person, which is simply not true. It's great that you're a good programmer, but if you're in a team, it doesn't matter. You do it as a team. And what really matters is, how can we do this? It's not about what can I do to make you look, bad, or the other way around. Oh, you're so good, it makes me look bad. And this is the kind of thing that is ego. This is the kind of thing that you learn how to deal with more spiritual things, and yoga is a very, very nice thing of that, I think. So yeah, that's a way to deal with this culture that I perceive as toxic quite often. Yeah, and you can make it better. If you just go somewhere and somebody's like, "Look at my code, it's great," and you like, "Yeah, your code is great," and if you can really mean that, then you can just forget about that thing. We're all good. It's all good. Yeah. You're good. I'm good. We're a team. It's great, and this is how you should work. Yeah. Instead of being like, I'm the best programmer in this team. Yeah. No, nobody should care about that. Yeah.
Unfortunately, that toxicity is out there. And we can benefit from that mindset. Yeah. That's a great piece of advice.
Yeah, you can change the whole vibe. You can change that kind of toxicity. No, whatever. If you bring in a better vibe, and I think that is. In the end, you're a programmer. Okay, you write code, right? But you don't only write code. You are responsible for more things than just writing code. You're also responsible for the team spirit.
Yeah.
Yeah.
So much more than just code. Yeah.
Yeah. Yeah. So,
Awesome.
yeah.
Well, thanks, Elmer. Really enjoyed our discussion or conversation today. And,
yeah, great.
Lastly, where can people reach out to you? Are you in the Pybites community? If not, please join.
I will join
LinkedIn.
after this. My name is
people go.
Elmer Bulthuis, and my company is called Luvdasun, Luvdasun. But you can find things about me on the internet. But actually, if you really want something from me, just reach out to me. Yeah, because on the internet there's not so much impressive stuff of me.
Yeah.
And if you want help with anything, I'm glad to help. If you have questions, don't hesitate. I'll just make time and see if I can help you. Yeah. I like to do that.
I think we connected
love programming.
With some Rust posting, and we commented, and that's how we met, right? Just on LinkedIn.
I think we met because somebody said something about Rust.
Yeah.
That kind of triggers me.
Yeah.
I try to stay away from LinkedIn and all of that media, but if somebody starts talking about Rust, then I'm all ears, man. Yeah,
then we
definitely.
Have to stay around. Yeah.
Yeah.
All right. Thanks, Elmer. And have a great day.
Yeah, you too. Thank you. And thanks everybody for listening.
Great to have you on.
Okay. Ciao. Thank you.
Cheers.
Hey everyone, thanks for tuning into the Pybites podcast. I really hope you enjoyed it. A quick message from me and Bob before you go. To get the most out of your experience with Pybites, including learning more Python, engaging with other developers, learning about our guests, discussing these podcast episodes, and much, much more, please join our community at pybites.circle.so. The link is on the screen if you're watching this on YouTube, and it's in the show notes for everyone else. When you join, make sure you introduce yourself, engage with myself and Bob, and the many other developers in the community. It's one of the greatest things you can do to expand your knowledge and reach and network as a Python developer. We'll see you in the next episode, and we will see you in the community.